All right. Thank you so much, everyone, for coming to this panel. My name is Dan Garcia, and we're going to present about the BJC Middle School version 1.0. Woo! We've got a huge team working on this middle school curriculum. Let me introduce all of us on the panel. Uh, Lauren Mock is our project manager and was part of the key. She's been with us BJC for 10 years, I think, since early days. I don't want to date you, but in terms of how old you are. But it's great having her lead the project team for us in so many initiatives. We're translating BJC to Spanish. We're doing middle school. We've got high school. We've got PD. We got BJC Global. I'll talk about that a little bit at the end. We're going to other countries with BJC. Very exciting. So Lauren is the key to keeping all of us on track. Mary works at EDC, and Mary's been part of our high school curriculum for many years, and it's delightful to have her on part of our team. Pamela Fox is a newcomer to UC Berkeley, and comes from Khan Academy, and so delighted to have all of her curriculum expertise as part of our family. Deanna Gelosi comes to us from the Exploratorium. She's my graduate student, and she's amazing in terms of hands-on kiosk level young learning activities, and so she's anchoring some of our hardware curriculum. By the way, all of us are going to be presenting today, so there's a lot of handoffs for this, but it's great to introduce us. And Michael, everybody knows Michael Ball. He's helping us run SnapCon, obviously, and he's our Snap developer connection. And we're coming to the Snap team with some things we want to make changes about to make Snap easier for younger kids. You've seen some of that with the work that EDC was doing in grade school, and some of those things are coming to us thanks to Michael's initiative and thanks to Michael's working with the development team. So it's delightful. All right, get off the first screen. So I'm here to give you an overview, and then I'm going to pass it on to the other folks on the panel. So let me quickly a history of BJC. If you don't know, BJC stands for the Beauty and Joy of Computing. The beginning, it starts at October 26th. I remember the date because it was my wife's birthday, and I got in trouble for leaving for a conference when I wasn't there. 2008, CS Principles was formed. Jan Cooney, who was a thought leader in US's national space, she was an NSF program manager, held a meeting of many, many educators, high school teachers, faculty. What's wrong? How do we fix high school computer science? It's really broken. Only a small fraction of the students overall in the nation in the U.S. were young women, not even close to 50%. Even fewer of them were students of color. How do we do? How do we fix? Should we throw out APCSA, or should we do something different? And the solution was, let's make a new APCS course. Let's call it CS Principles. That was the beginning, October 26, 2008. We ran back to UC Berkeley, and I talked to Brian. I said, Brian, I see the writing on the wall. The name of it is CS Principles. What do we do? How do we take not only, how do we become a national leader? So we go back and we bring a lot of students with us in the curriculum design process. Colleen Lewis, famously, she's now at Illinois. She was a student with us. And we basically take what we loved of the old non-majors course in SCHEME, and we made it the new course, named it BJC, Beauty and Joy Computing. In fact, some newspaper reporters say all they did was change the name. It's absolutely false. We went to the whiteboard and we threw out all the things that we loved, kept the things we loved, threw out things we didn't like. We didn't want to have it be a text language. We wanted to have a graphical language. All of that. We wanted to keep recursion, keep higher order functions, etc. We then built this course, sent it to the national space, applied to be a national pilot. We're chosen as a national pilot. We partnered with Tiffany Barnes so she had actually taught a version of our course in the spring. We taught it in the fall. So we became 2 out of the 5 national pilots were BJC. It was amazing that early success. We applied for some funding, and Jan was happy to give us funding because we were in the leadership position, I would say. And we did some professional development for students around Berkeley, around the Bay Area. And then we applied for this really big grant, partnering with EDC. So delightful to bring them on board. That was Brian's connection that he made, and it was so nice to bring friends into the family. For the BJC for New York City initiative, $8 million to work with NSF to expand this nationally. It was actually initially only 100 teachers. It became 200 teachers, and now they're actually running it. Like, we built a system, we built a machine that is now generating teachers every year without any more money from us putting into it. So that was amazing. So that was all good. We had a national space. We were getting on 800, 900 teachers nationally teaching BJC. And I said, how do we bring this to middle school? What can we do to bring this to more students middle school? So I decided to teach 10 kids, my 2 kids and then 8 of their friends BJC, to do that. we developed, so I did this and we had a great year and a half developing middle school. And then I said, I'd like to do more of this. I want to expand this. So I applied for some funding and we got some funding to develop a middle school course. Deanna joined our team. We were so delighted about that. That was just great. And then in 2021, this year, we added Michael, Pamela, Mary, and other volunteers. We actually have volunteers who are going to be working in the schools with our students. And we've launched our first 20 teachers. We'll talk about that, but very exciting to have that. We went to so we're excited about where we are with this. And I also presented ideas for this in 2 previous SnapCons, and thank you to that feedback we got, which was this was way too hard. The original version was way too hard. 0.9, 0.8 was, so we slowed it down and we learned from all the feedback. And so thank you to this community for that feedback. We also, Mary was very good about, let's have some design principles. As we're going forward in this open design space, obviously you have your version 0.9, what you did, but let's do it right. Let's have some design principles. So in addition to the design principles of experience before formality, which came from EDC in our high school version, we had these kind of 5 design principles. And I don't want to put an ordering to these because I really think these are all powerful. There's a spine of the CS ideas, but it also has to be engaging and inclusive. We need to support teachers and we need to have chances for kind of open computational problem solving ideas where there's also bringing in the societal impact, the computing in the news we brought back in, the idea that you can have open-ended problem-solving problems where you're not just taking down the path to say, do this, do this, do this. They need to then go find that space there. I think that surrounding this whole thing, if I had like a watermark across this whole slide, it should say hard fun. Really Seymour Papert's idea that we're going to have really rigorous, powerful CS ideas, but it's going to be fun. That's the spirit of this. And we're taking, again, the spirit of the high school version and some of that. We stand on the shoulders of giants in terms of that, but it's just really exciting to bring. I think if you look at this course that we're proposing compared to every other middle school course, there's more powerful CS ideas than any other course. And so I'm really excited about that. Just good stuff. So there are 2 programming paradigms that are predominant in intro CS courses. And the right one is the one that's in almost every course first. They just hit you over the head with a huge hammer called the imperative or sequential hammer. Every code.org exercise is like this. Every early programming exercise you have in most middle school curriculum is like this. If it's game-based, it's probably like this, which is sequential. Do this, then do this, then do this, then do this. It's using command blocks. The data is typically mutable, so the operators on lists are insert things, delete things. That's what Scratch gives you. It's all about mutating the data and working with this and working with there. It's all about lots of state. It's all about having state that you're floating around. And well, the list is in this setting, and teachers end up teaching their students, well, make these box diagrams, have A, and label it as a box by A, and the value in A is there. And as you go through the loop, you have to update what A and B and index. It's just so complicated for that. And debugging is really hard. We decided to have a different approach. We wanted to have a functional approach. And those of you who are familiar with Snap know this approach. But the idea is you have functions, reporters, predicates, but not commands. Data is considered immutable. You can't change the data. If I want to add 1 to the front of it, I don't use insert, I put 1 in front of, and that returns a new list rather than mutating and modifying the old list. Functions are considered as data. So that's powerful as well. We have functions can be inputs, they also can be outputs of functions. And debugging is easy. And Mary wanted me to add a slide now. Thank you for this. Why did we choose functional programming approach first? We're really saying to all our teachers, and 1 or 2 of them are actually on the call now. I'm so happy to see you here. This functional approach is mandated because we believe that the mother tongue, which is often known as the first coding language or even first coding paradigm that the students learn, it's not just, obviously, if they're first learning Snap is their mother tongue, but it's really the paradigm. What's the first mother tongue paradigm we have? And our thesis is if you come with, and I started with this, Brian and I are both from MIT, we both kicked Lisp and Scheme as one of our early languages we used, and we believe deeply that if you have a functional programming approach to new problems, then kids will think of a functional solution to things. If you give them a new problem, they'll think functionally about it, rather than how do I make a list of 20 commands and reorder them in some way? No, it's about how do I break this into smaller blocks and smaller blocks and smaller blocks that have no state to it. It's really beautiful. Code that mutates lists and crashes midway through leaves lists in inconsistent states. But if you have lists be immutable, you don't have those problems. Again, our authors love schemes. And that's part 1. Part 2 is because we have functions as data, map, keep, and combine are these vanilla functions we give them like from scratch. They just show up. And now you can use these and not have to worry about iteration, for loops, for each loops, recursion, all the things that you normally have to do to kind of process something, process a list, process every character in a sentence or in a word. You don't have to worry about any of them. It just is done automatically for you. So there's this using abstraction. The most powerful idea of this course is abstraction. We say that over and over. And by using MapKeep Combine, someone else does the hard work. How does it work? I don't know. I don't care. It just does what it does on the spec. I don't know how MapKeep or Combine are written. It's beautiful and elegant, and it's all about abstraction, hiding the details of how this is done. No worries about index variables and incrementing it and running off the end of the base case. If they stay with CS, MapReduce is a very powerful paradigm that's used. We teach it in our parallelism course to graduate students, and students in middle school are learning the ideas and principles behind MapReduce, which is used in a more complicated way, obviously in C++, etc., with these graduate courses and at Google as well. So here's the overview of middle school year 1. We've got so far, left part of the slide is the first semester, the right part of the slide is the second semester. We've kind of rethought this. This is mostly what I showed a year ago, but we've kind of tightened it up a little bit. We start with functions and data. How many exciting projects can we have to grab the kids in there where it's all about there? And we're actually going to walk our way up and through higher functions, just using them, not talking about how they work, just what the spec is, what they do, not about how to actually do it. It's just wonderful. Use the powerful tools and just use them, and kids do not get scared about them. They're exciting. Now, how they work, how to write them themselves, that's a different thing, but they just use them in a very nice way. There's no recursion. Right now, it's just using it below the line. Maybe these blocks are implemented recursively. Who cares? They're just blocks you can use. Minimal command blocks. At the end of the day, we're going to have them probably show the output to the stage or play a sound, but you'll do everything up to them. It was going to be functionally. Unit 2 is where we bring in some of the iteration sequencing. The core CS principle isn't sequence. That's not an idea. That's not a big idea, sequencing, but it's using those kind of style of projects where you're doing more things, where you have several blocks do something. We're going to be playing with images, playing with sounds, lots of fun. I'll let Pamela and Mary talk about that. It does require Unit 1, and there's lots of opportunities for a big project at the end. And Unit 3 is hardware, and we're going to have a microbit, and Deanna's going to talk about that. So here's a quick timeline. Unit 1 and 2 is in the fall of 21. It's actually being taught by 20 teachers or some fraction of our PD folks from the summer. Unit 3, the hardware is going to be spring of 22. We're going to have Unit 4, still designing on that design. I have a year off to work on this. Should be a lot of fun. Maybe think about machine learning or AI or something fun. Maybe some games in there. Maybe some graphics in there. I have some units from my version last year that we can bring in. Unit 5, again, is still out there. So we want to have a 2-year curriculum. So right now we have kind of this path for this 2-year curriculum, and 1, 2, and 3 are in the process, and 4 and 5 are still kind of ideas on a whiteboard. All right, and I'm going to now let Mary and Pamela take it over and talk about semester 1. Thank you so much.
Thanks, Dan. So I'm Mary, as Dan announced me. Dan, would you like me to share slides then?
Sure, yeah, if you can.
I will do that. Great. So as Dan pointed out, our first semester is units 1 and 2. Unit 1 takes that functional programming approach, and predominantly we're all using functions and reporters in Unit 1 with a little bit of commands just to display on the stage what we've created with our reporters. So we start off with an introduction to Snap that involves some offline activities where students are learning about how precisely computers follow instructions. And then they start creating their Snap accounts and exploring how to drag and drop the blocks in Snap. In Lab 2 is our first real project. It's called Super Short Stories. We'll look at a demo of that in a few minutes. It's an opportunity for students to drag and drop blocks in Snap, to create blocks, and to explore lists and randomness in a very experimental format. In Lab 3, we do a project with data where students are creating a research question, collecting data from their peers, cleaning that data, and creating a visualization of it. There's a demo here in the corner, and then Pamela will show us a bit more about the activity later. Then we go on to a pixel manipulation project where kids are taking pictures of themselves or whatever they would like from the internet and manipulating the RGB values of those images so that they can have some fun experimenting and customizing projects while they're learning about RGB pixels. And that's another project that we'll see a demo of later. We go on to data representation, data encoding and decoding, and routing data on the internet. And then we wrap up with another data activity where students are collecting numerical data from their peers and then creating functions to sum that data, average that data, find the greatest number or the lowest number in a data set using higher order functions. Then as we move beyond our initial introduction to this functional programming paradigm, we move into our sequencing and iteration unit. This unit is where they start to learn about Boolean operators. They're looking at predicates and control structures. We've got some exciting projects using machine learning and a movie recommender. They have a song player that I believe is predominantly functional still at this point. And at the last minute, we throw it into a command block and they're able to hear what they've created. We have an exciting customizable greeting card activity. We have an Emojify activity, which does a nice job of balancing between the Snap programming interface and social implications, because we take a look at bias in emojis, and we'll look at that together again in a few minutes. And then we have some sound projects. We have an oscilloscope and a frequency analyzer that we've borrowed from Jens and Jadka on the Snap team. We saw some stuff from them and we said, this is amazing, we've got to have it in the middle school curriculum. And so we're bringing that in as well. And so next, I'd like to do a quick demo of our super short stories project. This is one of our introductory activities. Students have an opportunity to explore the impact of changing input parameters or input arguments and seeing the impact on the output of the block. They explore nesting reporters within a reporter, editing reporters. They get a preliminary introduction to lists and randomness before formality that comes later. So they get this experience before formality. We take that approach with our curriculum. And then we have an opportunity for students to create reporters. So I put a link here, but I'll show you a quick demo. You can play with it later. It's just a reporter that reports a very short story based on the inputs added to the block. So we could change the inputs. We can change the color to blue and cats to dogs, and we get a different story. The happy teacher jumps through Central Park and races over 3 blue dogs eating stir fry. So what's nice about this is we have the opportunity for students to start dragging and dropping blocks. They're moving in a random feeling, a random job. They can click the block and see what they do independently. They can open the block and edit it and add an item. We're getting this very brief introduction to lists where it's very intuitive. What's a list? Oh, it's a list of actions. So we could add an action here like, let's see, we could have jogging. So we're gonna jogs, and we can add that. We have an opportunity for students to explore duplicating blocks. So it's really just an introduction to the Snap interface and how it works. And then each time we click, we get a different story based on the random items that are selected from each of those lists. Students also explore random in that project. So we're not formalizing the idea of random numbers yet. We're just experimenting with it and using it to embellish our project. Then we actually even realize later on that if we use our random animal block, we can end up with sentences that don't quite make sense. The scared musician jumps through the zoo and jogs over 14 blue elephant eating stir fry. And that's happening. We're getting 14 elephant because our random animal is singular and we want a plural animal. So we can actually use the join block. And then this is an opportunity for students to learn to create their own block. And as they move forward in their progress through this lab, they can actually edit the original story. They can create their own inputs and restructure the story. So they've now created their own blocks, and then they can even create their own random blocks, like for example, a random sport or a random school subject they could add to the project simply by copying and pasting the code from one of these other random blocks and adding their own parameters. All right, we're going to move on and take a look at our Pictograph project with Pamela. Thanks so much.
All right, hello everyone. So I'm going to show a few more of our activities. So Pictograph is, I think, after that activity. So this is an activity to both, get some more experience with reporters but also go through the process of one aspect of the process of data science, right? There's a lot of steps of data science, right? But so in this one, they're actually going to be defining a research question, like, very important questions like what their classmates' favorite ice cream flavors are, or maybe they'll come up with something more pressing than that. They'll collect the data, they'll clean the data, and this is actually, this is related to the CSTA standards, which we are aligning to. So cleaning data is an important part because, of course, mint chip is exactly the same thing as mint chocolate chip, I think. Then they'll analyze it and visualize the data, right? So they'll go through that process. So the first part's actually kind of unplugged, depending if they do it on paper or in a Google form. But then we bring our data into Snap. So here we can bring it in. So let's say we're doing the ice cream one, and I'm trying to remember what people said. Oh, there was like some rocky road. There was some weird stuff. We'll say like rainbow sherbet, and mostly mint chip because that's the best. Okay, so we've digitized our data, and we can take a look and see, okay, it made a nice list. The next thing we do is count the data. So this is a block, and this is also, as Dan was just saying in the chat, this is a little micro world where I'm only showing the blocks that they need to use for this activity. But at any point they need to see everything, they can just right click and show. But by default, we're doing micro worlds, especially in the beginning activities. All right, so now I'm nested in this count data reporter. So I click on that and I see that it's basically done, a group by where it's counted each of the things. So we see mint chip and vanilla are in the race. I'll just have to fudge the data just to, important. So now we see mint chip is ahead. Beautiful. That's how I like it. All right. And now we're going to use a command block. So we do introduce a command block here, but this is generally what you'll see in Unit 1 is that if there is a command block, it's just one command block to get one thing showing on the stage or one sound playing. But it's not a sequence of command blocks, right? It's just that we want to draw something and it's nice to see it on the stage. So so it says draw a pictograph with emoji. All right, so I can either enter, I can use my little emoji finder here on Mac and enter something, or I can use what's in the drop down. And as it turns out, there is an ice cream in this drop down since I'm the one who made it. All right, and then we can give this a title like fave ice cream flavors. And then we're gonna drag this whole thing into here. All right, and now, moment of truth. All right, we have our pictograph. We see mint chip in the lead. And we can do a little more customization now. We could also, if we wanted, we could sort, although actually we seem to have already gotten a sort, but let's, the way I typed it, but let's do another sort anyway, because we have a sort data block that I wrote this morning. So we can sort by smallest to largest. We wanted to do that. And let's re-click and see what happens. Okay, we could also do by alphabetical ice cream name. We could do largest, smallest, which is what it happened to be anyway. So there you have it. That is the visualization of the activity. So this is kind of the whole process of doing a data analysis that they go through. And hopefully they get to learn some cool things about their classmates and have a fun graph to show off at the end. Thank you, Mary. All right. All right, so here we go with the, let's go with the next one. I don't know if I'm going too fast or too slow, but the next one is Emojify. So let's see, the first thing we'll start off with here is, let's start off in the actual Snap project. You can once again see a micro world here, and this micro world has a few things. So this project actually has a bunch of different text transformation things, reporters that transform text. So, let's just try some of these. So we might say, oh, I should clear my screen. I don't know how to clear it. Okay. All right. So let's say, so Emojify, that's the highlight of this one. So I type something in here into Emojify, and then I click it, and let's see what happens. So it actually replaces things. So let's say, I'm sick of cake. There we go. So it replaces some words in here with emojis. And, so it depends what you're going to type in here, whether it's actually going to match it or not. But you can type different things and see what happens. Then we have, let's see, so we songify, so we can type something in here and we get something that's surrounded by musical notes. Then we might want to uppercase something. And of course, these are all reporters, which means we can, we can nest them. So if we want to, maybe uppercase, maybe we want to uppercase poor baby first. We could do that, right? So that's the beauty of reporters, of course, is you can do all sorts of nesting. Let's see, Clapify. This is something popular on social media. So we've clapified it. We've got do it. And then a mystery block. What is even happening here? This could be a fun one to see if students figure out what happened. We seem to have lost all our vowels. All right, so we've played with some text transformation reporters here. Now, if we want to, we could actually draw this out on the stage, because I kind of think it's always fun when you can draw things. I spend like 3 hours a day drawing with my toddler, and I'm completely okay with that. So I think we always should be able to draw things out. So we can use a single command block for that. Let's drag in one more. Emojify to make my little conversation. I need more money. All right. And then we click that and we see it written out in our iPhone screen. Okay. So here we have the, a text conversation that has happened. So this is, an early activity where they just get to play with these, but then we really do this deep dive into this Emojify block. All right. So how does this work? How can we add to it? So they actually can edit this and edit the Emojify word block. And if they want to, they can add another mapping here. So if we want to, let's say, I don't think we have cupcake yet. And I think my toddler would be very mad about that.
I think you have cupcake right before it.
Do I really? I must have already added that one.
You've added cupcake.
Oh, we should add waffle, because Michael really likes waffle. And I found that there is a waffle emoji. There's probably like 3 cupcakes in here. It's probably like all I add. All right, waffle. All right, waffle. All right. So here we go. We can add a new one. And so that means I need more waffle. Then we see waffles. Okay, so they can add that. So that's all the programming part. Now we go into the actual, talking about the cultural implications of emojis. So emojis are really interesting. There's multiple brilliant TED Talks from people talking about the history of emojis. Somebody who's created what's called a bonobot, alternative emojis to be able to express things from other cultures. So there's a lot of great discussion about emojis. What do they represent? A lot of times the emoji visual representation is tied to whatever culture designed that emoji, and may not reflect all cultures. So that is what we get into in this discussion. So there's actually a worksheet which you could have them fill out or just have them do as a discussion. I did, and I did the worksheet myself, so you can see how it might get filled out. But you could also just do this as a discussion, pair discussion with a classmate. So you pick an emoji pair in the Emojify block and answer questions like, what does this emoji assume about the culture of the person using it? So I picked dancer, which I think is really interesting because I think it assumes a lot. It assumes blonde, assumes a particular dress, it assumes female presenting, heels, a lot of things. And there's so many different kinds of dance that there's obviously a lot of assumptions happening here. What other meanings could the word dancer have? Are there example phrases where this emoji would make no sense? So I said, I saw an amazing hip hop dancer on the train today. I don't think that looks anything like a hip hop dancer, although it would be kind of fun if that happened to be their dance. And then what other emojis could this word map to? So then I looked through all the emojis, and these are the only dance related ones, and none of them are particularly abstract, good representations of dance. So then that's good fodder for the next activity, which is emoji design. And that's where the pairs will actually design an emoji. And this is all offline, not doing this part in Snap. So you could do it digitally if you want. I did it with some little sketching app, but you could do it, on paper. So this is we're proposing a new dancer emoji. And then this is me trying to come up with like the least culturally specific dancer, but still, recognizable dance. And it's actually really difficult and tricky to do. So I found this fascinating to try and think like, how can I just abstractly, represent dance in a way that would be recognizable to people in multiple cultures. And then I gave alternate meanings and an example usage. So that's the Emojify activity. There's a lot of really interesting things to do about emojis. There's even more things you can go into in emojis about how they're technically implemented, because they take up multiple bytes in the computer and all these interesting bugs happen. And even the fact that this message here, do it, takes multiple lines is due to the fact that emojis take up more space on a computer, but then they don't look like they do. So we think there's a lot of really interesting stuff, really a lot of interesting stuff you can explore with emojis, and that is the Emojify activity. And now finally, let's do pixel manipulation. All right, so that's the final one I'll be showing. So this is related to the standard about understanding how data is represented, because of course images are represented in pixels, and then pixels themselves are usually represented in RGB or RGBA values. So let's go into this one. All right, so we do have a few single command blocks here because we're rendering the image on this stage. So the first thing we have is this use costume. So we'll change it to my face. And this is what the students can do as well, as they can use the webcam, or they can upload a picture here. And we encourage them to do that. Or maybe their teacher's face, if any of you want to give them your photo to mess with. I think that'd be very fun. So then what we can do is mouse over the image and just look at it. So there's my eye. There's my other eye, just creeping on you. So you can look out and you can see, it shows the pixels that are underneath the cursor, and you can see the grid of pixels around it. And you can also see the RGBA values for the center pixel under the cursor. All right, so we've explored some pixels, and then we're going to start using some reporters, and we're going to build them up. Okay, so the first thing we see is like, okay, we've got a reporter to report our costume. Okay, that's cool. Now we've got a reporter that will report the pixels of the costume. So then we start getting one level lower of representation. So this gives back a nested list, or a table of RGBA values for each pixel. And it's a very, very big table. And yeah. Okay, then now this is the first time potentially that we're going to see map. So this first usage here is going to grab the red color from each pixel. So we're going to map color red from pixel over the entire pixel list. So for every pixel, it's going to grab just the red color, which is that first column, and then output just that first column. So here we have the list of just the red pixel values. So, when talking with students, you can think of that is that if you have a spreadsheet with all these multiple columns, this map is just taking that first column. Then what we can do is turn this back, because if we want to make an image with this, like, so here we're trying to make an image with just the red values to see what that looks like. If we want to make an image, we still need to have something for the green, blue, and alpha values. So like 0, 0, 0 or 255, 255. So that's what we have another reporter for. And this one fills in 0, 0, which would be 0, 0, 0 is black. And then 255 for the opacity. So it will be fully opaque. Because if it's 0, that's not going to be very fun. All right, so now we have this. So now we could actually set this as the costume, and that's what this next thing does here. So we're going to see what happens. All right, so then I turn quite demonic. No offense to demons, I guess. But they're known to be red. I don't know if any demons are watching. Okay, so that was a cool map. Now we can start doing fancier maps. So this one does another map, which switches up the red, green, and blue channels. So we'll see what happens here. Actually, and I built that one off my red. So let me reset that to here. So you can build the filters on top of each other, or you can start from your base, from the unfiltered costume, whichever one you want to do. So here we swap some things. Yeah, now I look like an alien. No offense to aliens watching. All right, now of course students could swap around different things, and then in this one students could play around with different things in the drop down. So there's a lot of things students could play around in all of these. This one here is going to brighten the whole image.
Pamela,
Yeah.
include in that same one before on the top of the screen, including convert it to grayscale and decide if you meant red, you could say, well, which channel would be the best channel to grayscale? If you had to go to grayscale because you had a printer, which channel would you use? And so you're using the same tool, you just choose all reds or all blues, and that's the picks a particular channel. When they typically do it, they often combine channels. It's just an easy, it's an easy kind of little fun thing already with what they have, just by choosing different parameters. It's so great. Such a nice project.
Write that down. Because that's a good thing for teachers to bring up. Then we can brighten, but take a little red out because I feel like I'm always sunburned. And then finally, we can posterize the image. And of course, at any point, we can use the pixel viewer. So the pixel viewer is another sprite that is communicating with this one and finding out the pixels of it. So all throughout this, you can be checking out the pixels to convince yourself, like, so when we did this red one up here, we might not believe that it's fully red. But when you look at it, every single pixel, you can see that it's something in the red and then 0, 0, 2, 3, 5. So you can really convince yourself that this is truly how it works. All right, so that is image manipulation. And so for all of the activities, there's going to be student-facing guides. And so here's an example for image manipulation. But also I've been trying to create Google slide versions too, because we've gotten a lot of feedback from teachers that middle school students don't read. Well, or hopefully they read a little bit. I think that's good for their future. But you might prefer doing a follow along, up on this screen. So you might prefer using something like the Google Slides, or you just do the follow along and you don't use any of the formal materials and you just base it off of it. So, trying to make things that'll work for all of you. All right, that's all.
Woo. Great job. I think we're handing it off to Deanna.
All right. Hi, everyone. So I'm going to talk with you all about semester 2 or unit 3, which is hardware. So when we were thinking about, what type of hardware unit we wanted to design for middle school, there were so many ideas that we started with. And the direction that we decided to go in is to really lean heavily into microbit. And microbit, there's a lot of really amazing things to love about this particular tool. One is that it's fairly low cost and pretty easily accessible to obtain. And the idea that every student could have a piece of hardware that they were working with throughout the semester was a really strong and compelling reason to go with this microcontroller. And some things that I particularly love about it is that there's a lot you can do with things that are just built into the microbit on board. So it already has things like a light sensor, it has 2 buttons, it's LED screen. There's so many possibilities of things you can use that for. And also it has some input and output pins, but just with the microbit itself, there's so many different directions you can go into if you start using different types of breakout boards. So I love adding things like servos or additional LEDs to projects just because, there's just even more that the microbit can do and can power. And that was the basis for thinking through the hardware unit. And in terms of different types of projects, the main story to this arc is that we're really trying to start with a low threshold of activities and experiences for students. So thinking about what types of projects can they do just with a microbit, so without any of those extra breakout materials, and then start introducing those additional materials through future projects. So starting simple, thinking about building an interactive pet, maybe like a Tamagotchi or a type of creature that has not yet been seen by the world, then moving into designing a game that can be collaboratively played, looking into motions and mechanisms, so starting to introduce motion through adding servos, taking a little bit of a detour looking into e-textiles, so different types and qualities of materials that are also conductive. So looking into conductive thread and maybe doing some sewing. Also looking into light and shadow. So there's so many beautiful different types of LEDs like neopixels out there. So thinking about what sort of immersive experiences can you design using light as a material. And then also making with multiples. Microbits can talk to one another. So what sort of interesting collisions happen when you start having microbits communicate directly with one another? And then these core projects are all setting up students to then design one big collaborative project, which in this case is a collaborative chain reaction or a Rube Goldberg machine. So the idea that all of these experiences throughout the semester then build students up to be able to make their own section of a larger chain reaction machine. And I've done this experience with only analog materials, but once you start adding these digital tools and technologies like microbit to a chain reaction experience, it just ups the ante like 10 times. So it's really exciting to see how those ideas that were, sparked during the semester then come full circle at the end. So in the spirit of thinking about what would be a fun demo to share with you all today, I wanted to share a project with you that I was thinking about when I was imagining the design a game project of the semester. So one game that I really loved was at an arcade, and it's Skee Ball, the game where you take a ball and you roll it up a ramp and then you try to land it in one of these different pockets. And to me, this is a really great example project of what the spirit of this hardware unit is about. It's using the microbit both to signal when the ball has landed into the certain number pocket, but it's also the display. So displaying the score that you've so far achieved in your game. And it's combining both digital materials as well as physical materials. So using things like cardboard and alligator clips and aluminum foil to be able to make this game playable. So I have a little GIF here, but I thought, wouldn't it be more fun if I also tried to, now I have a, now I have a background on, so I don't know if it's going to show up as well. Maybe if I position myself. So the same idea with the game here is that if I'm going to just start my snap project. If I have my aluminum foil ball that I can, if it makes contact with one of the tubes, it will then start helping me add up my score and add to my points. But really, the hardware unit is just, it's playful. It's about letting learners find the elements of physical computing that they're really excited about and giving them prompts to get started in lots of different directions to work individually and collaboratively on these learner-centered projects.
Perfect. Thank you so much, Deanna. And I think we're going to have Lauren talk about logistics, and Mary, were you going to share slides, or Michael?
Yeah, I'll share slides. Lauren, would you like me to take these slides today?
Yes, please. I don't know what's going on my end, but thank you.
Okay, perfect.
So we're just going to talk a little bit about what we've been doing with teachers this year. This past summer, in fact, last week, we did our first PD session for middle school. We did a 5-day training with gosh, what do we have? About 20 teachers, I think. Oh yeah, 20 teacher participants. And we did a 20-hour training over the course of the week. It was lots of fun. We got excellent feedback. And what we did is we had the teachers reviewing curriculum pages, reviewing the projects. We worked through the projects together. They had some time to explore them on their own. We had teachers presenting computing in the news stories to our group. And we got a lot of great feedback from our teacher participants. So next year, we are planning to have these teachers implement both units 1 and 2 in the first semester and unit 3 in the second semester of the year if they have a context where they have students continuing all year. If not, we have some flexible options for teachers depending on their context. And then we're having our pilot teachers attend the PD, teach at least one of the semesters, including Unit 1, and then providing materials throughout the school year, and then participating in interviews with us and potentially also focus groups. So this is how we're going to collect some feedback to make improvements for next year. And then our plans for the future are to create a second version of the middle school materials that we've already developed. So that'll be units 1 through 3, and then create these additional units that Dan talked about earlier, units 3 and 4, to create a second year. So some of the folks who've taught BJC Middle School this year, by 2022, 2023, might be teaching that second year of materials. We're planning to have a new cohort of teachers go through our PD next summer, and then also a workshop to bring our first cohort of teachers up to speed on these new materials. And then we'll go through a second year of implementation and feedback on our new curriculum materials. Next up is Michael to talk to us about software support.
All right, and I can just take over the screen sharing. Actually, let's see. We'll just do that. Cool. Do I sound right? Because I hear a tiny bit of like feedback myself.
You're okay. You're a little loud, but you're okay.
Oh, okay. Well, that I can fix. It just sounded all right. Anyway, so the first thing I was going to show is what we have today in Snap. So we have the single palette option, which you can play with all of this in the development branch of Snap. So that's linked there. It's just /versions/dev on the Snap website. But essentially, the single palette is on its face, just all scrolling blocks in one view. Part of the philosophy of this was not necessarily to show students, I don't even know what it is now, but something like 200 or 300 blocks all at once, but to show them, 2 reporters, a list block, a custom drawing block, and have like 5 blocks that they see in their view, but from all different, categories of Snap. So that was one of the driving factors behind that. We have not played with this yet, but one of the things that we're really thinking about doing as well is now using the custom categories feature of Snap to make certain blocks that either students work on or maybe pseudo primitives that we provide with projects to be more clear. So have a sort of BJC category that exists for all projects is an idea that we're exploring. So those things exist. They will be definitely in version 7 when it comes out that we'll be using. The other thing that we've been working on is better support for error outputs. So if you haven't used Snap much before, you may not be accustomed to what happens when you get an error, which is really, it just says, error inside a custom block. So what we're trying to do is expose inside this block, at least the location where it errored. In this case, expecting a list but getting nothing. This is just a fairly simple command block. Eventually, we'll work towards things like a larger stack trace or something like that. But really, the changes break down into a couple categories. So micro worlds type changes, things that sort of remove features that focus attention, things that are debugging support. So improving error messages. We're going to work next on inspecting nested functions so that you could sort of just report the inside of some expressions without having to pull blocks out. And then things like importing and exporting data, just making those things easier, sort of reducing barriers that existed. The one big challenge, and this is, I think, something fun to think about, and John Maloney, if he's here, I'm sorry, but like Scratch's design has not been the thing that sort of encourages people to work on functional programming. So one of the things that we're thinking about is, how can we adapt the interface to really sort of encourage functional programming as a first class item? And so these fall in the much broader, longer changes, but we're really hoping to think about, what if we have sort of an execution log or a Jupyter notebook style where you don't even use the stage as your output mechanism, but you have, speech bubbles being large, present things that you can interact with. You have a log of all your reporters that you've executed and what they returned, and you can replay them. So there's a lot of ideas there that we are still exploring, but hopefully sort of pushing Snap in the direction of of making working with functions, the sort of primary way, and not doing every kind of interaction through the stage. Absolutely, like Pamela said, that there's still going to be a lot of projects in the curriculum where the stage is a great way to be interactive, but sort of giving students the affordances that make it just easier to work in a functional first environment. And yeah, that's it for Snap. But if you have ideas, we're happy to hear them about Snap or really anything else.
And Michael, thank you so much. Well, first of all, let's give a hand for all of our presenters. Thank you so much for capturing this so well. Wonderful. Great job, everybody. One of the things, just to add to Michael's list, is right now, and many of you have played with looking at the pixels. When you click on pixels of, you see the pixels. Kind of allowing people to click on something and see a picture, but then if the picture is made up of pixels, kind of like what's behind it. So it's a little bit like, when you click on something that returns a sound, should that sound reporter speech bubble be a sound that you can click on and play like a QuickTime player, or should it be a list of things? So I feel like whenever you have a list of things, you want to almost say like reinterpret this single list as a sound. Bloop, all of a sudden. So any list, literally any list. If I say list 1, 2, 3, I should be able to click and say reinterpret this as a sound, and then bloop, there's a little play button and it'll play the 3 samples of the sound. Like that's the idea. If I have a 2D list that happens to be 4 wide by 100, if I just made it, literally hard-coded it, I want to say reinterpret this as a picture, and bloop, it showed me a picture. So I feel like there's another piece to it which we didn't list, which is like, how do you get to the, flip it to the backside? Here's what it is visually. Here's a, that kind of thing. How could you how about this? How could you reinterpret a picture as 4 parallel channels of sound? What if I have 4-part harmony? And right, so it's almost like thinking of data in this really beautiful, mutable way where I can reimagine it as different ways. Just really fun stuff.
Yeah, I would say that falls broadly under the category of making speech bubbles a first-class interactive thing. And there's, one of the simple things that we will hopefully start with is just if you have, 4 values, figuring out, or even if we have color objects, right? Like, is that a color that can be reported? But making them be something that you do want to interact with, and figuring out, that interacting with data as a piece of data and not necessarily just a display mechanism or something playing in the background.
Yeah, exactly. And by the way, I'll just say, this never gets said, but I just want to say, I know of no other curriculum that is able to connect with their software they use as closely as ours. If you're teaching a Python middle school curriculum, you want a feature in Python, it's not going to happen. I mean, it really isn't going to happen. The fact is, we're so closely tied symbiotically with the Snap development team that it's just wonderful to say, we would love to see this. And then, it takes a little while to get it up and have the ask there and get it implemented. But I know of no other curriculum that's able to be as tightly woven with their software that they use. It's just been so refreshing and delightful to do that. It's been great. So open to other questions that are open. I've been talking mostly. I haven't been looking at the chat as much. Other kind of open questions we have for folks. And by the way, so I did see a comment of, can I borrow this for high school? The answer is yes, yes, and yes, right? We're going to put things online. It's free. Everything BJC's ever done is open source and available. So feel free to borrow and steal and remash into your own curriculum, however you want, including bringing it to high school. We've obviously stolen a couple of ideas from high school to bring it to middle school and soften it up, but that's the current space.